last semester.
No.
All of them. All of them.
Who will teach us today?
I will keep it. Fred will, he has
No.
Yeah.
What do we?
Electron in a free space.
Electron in a free space. Ah, okay. Yes, yeah. Electron in a free space. So America's the perfect place for an electron. The land of the free.
Oh.
Okay.
That's Martin Van Buren.
Oh yeah, I have.
10. No.
Yes, I have forgotten to print and distribute. The plan was to print money and distribute in class.
It's not for educational purposes.
It's it's legal for educational purposes, and those money are not valid anymore because Germany changed German marks to euro like 20 years ago. So what do you see? What is? Oh no! This is your homework. It's important, but it is boring. Let's go to the banknote.
Wait, we have homework?
Oh yes, already two in a week. The second one is a little harder, so you need a weekend.
Second one is due next Friday, like a week from Friday.
Wednesday.
Here's the reason.
For your music class.
Music?
I dropped my minor,
I finished it.
so I dropped like 5 credits because I was no longer doing the minor.
We talking about the third problem? Now we're using. Yeah, actually, I have kind of a question on that. I understand how to do the like trig properties, but I don't know how to.
Just open Wikipedia for this.
There's 3.
Select the one which is appropriate. If no idea, just try all 3 one by one. We'll talk about it a little.
Roll out.
I understand how to add the trig so that it's like 2 cosine alpha cosine beta. But that's with assuming that it's alpha beta, but we have alpha beta and then like third.
But you can
But it's just a constant. Well, how would you, I don't know what to do with it.
just combine third and second in beta. Like first is alpha, second and third is beta.
Oh, there's only 3 questions.
Okay, I can do that.
Yeah, this the first homework, right?
First 2 sound very easy.
And the third one is also easy. I feel ashamed for giving you so easy homework that will not. Okay, so before we go to physical chemistry and electron in free space, what do you see on this image?
German Frank.
There is a curve.
So some nations show heads of presidents or some architectural things, right? And Germans put not only a curve, but also an equation.
Is that the Gaussian term?
Now, what's the name of the person? Yes. So basically, from physical chemistry point of view, we will be studying electron in a free space. From the applied math problem, we will be studying Gaussian function and how to integrate it. If you don't care about science and you are like skilled in math. Okay, and one can do perfect chemistry without physics, but with good math.
Sounds like we could finesse it.
But integrating Gaussian function is well, you do it only once in a life because it is a unique integral. But in a purpose of teaching similar class in the future, you may learn the trick how to impress whoever you will be educating. Okay, so I'll probably mumble things. Yeah. Read. So what I was about. Yeah, let me just to wake up. I'll show. Let's go back. Yes, yes. This is a pure pleasure that Sam missed last time, right?
I'll just go back now to food poisoning, to be honest.
But it is recorded, and as soon as you are happy with this equation, you don't care what we did. So no, it's purple to measure hair.
Oh. No.
Oh, see, there is a brighter purple. So, what does this equation tell us?
Oh.
Yeah,
Summarizes the third way.
listen to the expert.
Say it's not a way to predict the future.
Yeah, from past to the future, right? And this is the way how people were predicting the future if they do not have computers in quantum theory. Yes.
Is this predicting the future of like a wave function?
Yeah, oh, yes, yes.
Future like of humanity. The future of future events that will happen to the world.
If no, you are still on camera, but Melody is hidden. Yes. Oh, okay. and I have an impression that we have only three person in the class, and
It just gives the impression that Alice is doing all the talking here.
uh,
Okay, so my question is, since we're predicting the future, are we predicting future possibilities? Like a probability?
yes.
Okay,
If someone can build a wave function of the universe, we can predict the future of the universe. But it will be too many degrees of freedom, and we'll be tired doing it. And on the other hand, if we as scientists are part of the universe, we need also wave function of our brain who studies this wave function of the universe. And then it's like a group of atoms studying another group of atoms, and it's a little paradox. But formally, yeah. But right now we stick with only 1 degree of freedom instead of many, right? Here is the logic. From simple to complicated. Clear enough?
Yes.
Good. So chemistry studies molecules, reactions. They're composed of ions and electrons. And electrons are attracted to ions. And it would be cool to predict their future for reactions or for some properties. But most molecules, except H2 plus, have more than 1 electron, right? And all molecules exhibit attraction between electrons and ions. This is interesting. This is really useful, but expensive to predict. We already touched it, like wave function of universe is complicated, and even wave function of multi-electron molecule is complicated. So in order to pump our mathematical muscles and get confidence that we can apply this equation, we need to select the simplest possible example where it can be applied, so that we do not overtrain our brains and do not get too tired or scared. So some heavy weight lifting, but not too much. And we want to avoid, so the problem that we are going to solve is almost useless for practical applications, but it is very useful as a foundation for next steps. So we want to avoid 2 difficulties. We want to avoid repulsion of electrons between each other, and we want to avoid attraction of electrons to ions. How can we do it? We can assume deep space, no stars, no planets.
Nowhere black.
No dust, only 1 single electron in the universe.
That bounces everything all at once, all at the same.
Huh?
There's a, I don't know if this is what you're talking about, but there's a theory that there's only 1 electron that exists in like the entire universe, and then it just constantly bounces between every single atom ever. That's mind blowing.
It is,
It doesn't hold much weight. But
this is a reason why I let you guys to present postulates of quantum mechanics. It is it is the subject where people try to replace calculations by hypothesizing and doing some interpretations, and it is very rich area, which cannot be either proved right or wrong. So it is a just stream of fantasy, which can be potentially correct, but it's.
I just need to ask, why would you go into an area of study that has no, you're never really ever going to be able to find a fine answer?
Because it's the independent.
for local trades.
Yeah.
That just sounds so
Sounds bad.
masochist of you. Like you're never gonna get a definite answer to anything you do, but you can have.
Which area of study do you mean?
Yes.
Which area of study do you?
Organic chemistry.
You are trying to deviate our direction of discussion from the constructive to inconstructive, which will please me, but will upset the course.
It just popped into my head because I'm like, I just want to know, like,
We can talk about this.
we'll do it after.
Yeah, but credit not for the class, but in my personal like scale. Good provocation. and brief answer. A lot of studies area are motivated by simple people, applications, and needs of industry, even if it is not promising scientifically. Oh, electron in a free space. So it does. If there is one electron, it doesn't interact with a second or third, right? So we get rid of one thing, and if there are no ions, it is not attracted to anyone, right? So now let's do this a little bit of intuitive common sense analysis. What electron in free space will do? Like, if we do not know quantum theory, if you do not believe in it, if you do not know these equations, but we already got like high school physics and Newton's equation of motion, what a particle in a free space does.
So it needs something.
But there is no anything.
Okay, well, just keep moving.
Going for.
Or I guess the question is, does it have momentum?
So whatever momentum was, we just set momentum as a variable, and then it will keep initial momentum.
Okay,
So if it was 0, it is 0. If it was like 10,
it just keeps its momentum.
okay. And now we neglect Einstein relativity, and we just do not limit ourselves in velocity because it is not needed at this point. Okay. We agree on this. Now we come to the idea that there is a probability to find an electron somewhere, right? So it is a distribution. And as time goes by, this distribution may change. So all these equations of quantum theory are designed for the change of this distribution in space and time. So there is two questions that we will answer in 2 weeks. Well, we can philosophically, by common sense, predict them right now, but we will prove them solidly. It will be an effort in class, in your homework, and you see that it is the easiest problem. So if we agree that electron can be approximately localized somewhere, which is already an assumption. So it is not spread over the whole universe, but it has an approximate location. And we can speak about center of distribution, like center of mass or center of charge. So the question is, how does the center of mass or center of charge moves? Would it match Newton's equation? Would it move with constant velocity? Yes or no? I don't know. Well, I know, but I will not tell you. Yeah, but yeah, by common sense, yes, but we need to prove it. It is not written in Schrodinger equation like d dt over psi, comma, but electron in free space will move on a straight line. we need to derive it. And the second thing, the distribution can be corpulent or skinny. It's like sharp or distributed. So the question is, how to say, width. How does the width of this distribution change? Would it stay constant? Would it get skinnier and skinnier? Would it get a little more distributed? What are your assumptions?
What?
Distribution of probability for electron in the free space. Like if we
Like pick one point that the probability that it would be there.
Suppose we have probability to find electron in the origin on like 1 angstrom from origin, 2 angstrom from origin, and the probability declines to the positive and negative. So it's condensed. It has some probability in the center and less as we go away. And then we can draw like half-width maximum of this distribution. So this half-width maximum, would it increase, decrease, or stay constant as we go over time? Yes. You can skip next 2 weeks. But we need to prove these 2 things. And
So I got the question right.
So as time increases,
The distribution increases.
like,
And so it becomes
increases or increases?
increases, gets wider.
yes,
Center, that it's just gone somewhere.
well, right now you are following Sam by or Elsa or any normal human by provoking common sense analysis and hypothetical verification that the solution makes sense. But now if you did read Wikipedia about this paradoxes of quantum theory, there is a nice saying. Well, I even quoted it in the email before you're presenting. There are like 12 famous interpretations of quantum theory, and one of them, instead of long things, stuff, shut up and calculate. Yeah. So and the 99% of scientists follow this one. So one can interpret when there is an answer as an equation, but before it is derived, it is much preferred just to follow protocols and convert all ideas in math symbols, follow math logic, and when the answer is obtained, to analyze it. And we are going to go through this exercise. Yes, I agree, because partial waves with higher frequency will move quicker and depart further. We will arrive to it. But it's 2 weeks of hard labor. Well, not 2 weeks, 2 weeks. It is like 6 meetings, about 6 meetings. Okay. Huh? Well, we are not working on this day and night, right? What else? I need to entertain you for another 25 minutes. I need to learn how to dance, and then the classes will go smooth.
Explain the question that I have.
That's.
No, I'm just taking a breath to go to the next chapter. By the way, about the dance in Australia, there is a competition, Dance Your PhD, and there's a Dance Your PhD. So PhD candidates can record video of their expressing scientific ideas in the language of dance. Then finalists are invited to Australia. They dance on a stage and get prize. But probably yes, but to participate first, you need to prepare your doctoral thesis as an entrance ticket. Yeah, absolutely yes. I don't mind. Probably the uncertainty principle can be expressed in this language, and many things. And I think if you record it, it will get a lot of hits on.
A lot of ironic.
So
Take time for their next winter.
Oh, easy.
what else do we remember from our previous meetings? Which concepts?
Hamiltonian.
Sure.
Hamiltonian, yes, good. We will use it. What else?
Oh, Hamiltonian and then a Hermitian operator.
I can certify that concept students teach students works perfectly with 100% guarantee, especially when a student teaches himself.
Is that accurate?
He was delivering this subject and he learned it and now answers question on this subject. So self-teaching works at least.
A little bit.
Yeah. So do you remember commutation? Swapping order of operators.
Yeah. Someone.
So differential operators or matrices cannot be swapped for free. Do you?
On the board.
But you remember the
Summations and things out of the integrals, then derive the.
no, it is when we derive this one. But before that. So when we were talking, I'm on one point of view, I'm wasting time instead of delivering material. But on another, if you don't have agreement, and we forget things, there is no reason to go further, right? So when we were talking about commutation, and we will talk about it again and again, then we also covered the concept of time independent Schrodinger equation, right? And then the concept of what we covered in the lab last Wednesday. So eigenvalue problem. And then in class, we did an example of reverse engineering and applying this concept as an illustration of an operator and function that love each other. Like, what was the example? Which operator and which function? So the simplest differential operator is differential means it has derivative. Operator. So simplest differential operator is, yes, derivative. And which function stays unchanged when you apply derivative? Yeah. One of my colleagues delivers some similar concepts to freshmen and delivers a joke which I do not find funny, but freshmen find. In a psychiatric clinic, there are two patients who are both mathematicians. And they are teasing each other, and one tells, I will differentiate you, but I'm exponential. Okay, and if, well, some find it funny. So what if we apply derivative over space? Then exponential should also depend on space, right? E to the power x, or e to the power imaginary unit, value of momentum divided by h bar times x. And this is something I can draw. Maybe soon I will turn camera to me and start drawing equations. It will be better. So e to the power minus I h bar momentum times x. So if we have a wave function of x in this form, what its colloquial name? What is a human name? Colloquial, human name, artistic name, non-mathematical. You all agreed. I didn't say this word. I was leading you guys to the right word, and by Hamiltonian is operator, and this is wave function.
Oh, is this the free electron?
It will be used. It is our main concept to attack the problem of electron in the free space. But okay, probably it's time to turn the mute this one. pull this up. And I will humbly focus camera on myself.
A little bit on it, no. Or have a little block.
So those are my limits. The things that are, so things that below will not fill. So I will rewrite phi equals E minus I H bar Px. Please give a name. If we good try. So by Euler equation, it is a cosine Px over H bar plus I sine Px over H bar.
God damn it.
If you do real, imaginary, here we have x. Cosine starts from 1 and oscillates in this plane. Sine,
Goes like.
Yeah, that's the other color.
yes. Thank you. I did it first time in 20 years. And sine goes up and down, right? If one takes x and y projection, it will go as a little spiral, right?
Yeah, we saw that.
I thought you are waking up in the middle of the night, and in PChem class we studied spiral, and the name of this wave function is. Oh, thank you. It's a probably different sport. If it would be figure skating, the highest grade is 6.
I don't know.
So since something is repeating with a period, with lambda equals h bar over p, right? Something that has a period is a yes. Okay. So this is a wave, but there are many waves. So one needs another adjective telling which wave it is. Curly wave, happy wave, joyful wave. So I'm terribly wasting time, but so it is continuous, but I'm not. My goal is not to torture you guys, but there is a very fixed name. It is a concept. So if we, instead of making things simpler, I will do it more complicated. And I need to stop sharing, otherwise it will not show the whiteboard. Yes. So e to the power I over h bar, and I will do here vector r, vector momentum as a vector times position. And then in the three-dimensional space. No. As long as where are my coordinates? X, Y, and Z. If our distance is increasing in the same direction as momentum, then these oscillations will happen. If you go perpendicular, nothing is changing, right? So the same phase, some of you told the word phase, the same phase of this wave will be equal in the plane which is perpendicular to the momentum vector. Plane. Yes. So what's the name of this object? Yes, plane wave. Oh, yeah, sure. Yes, I wanted to say it. Yes, right. Everyone wanted to say it. Just. Okay. So the plane wave is our building block to study the electron in the free space. In case the yeah, very humbly focusing on myself. In the case the electron is distributed over the whole world, it is not localized. And if it has a very definite, very known momentum, then quantum state of an electron will be a plane wave. It will be one of the answers for electron in free space. But it may have different values of momentum, so different plane waves are possible. And this is practically useless. Practically, we need an electron that is localized, like near origin or near some other thing. And this is a mathematical challenge. Okay. Questions? Suggestions? Okay, another 15 minutes of pure entertainment. I'm going to erase, but when you wake up in the middle of the night, you need to remember plane wave. Thank you. Instructions to take pills. 1 pill at the evening and 2 pills at the morning in case you wake up. It's like black humor. Okay. So, what do we remember from our last meeting? We do remember an equation that was here on the purple board, and I will just practice my memory. So, wave function of the future equals summation with index, expansion coefficients, phi n of x, e to the power minus I h bar e n t. Yes? And the question is to find c sub n, to find phi sub n, to find epsilon sub n. So they all are unknown. And then to perform this summation to get an answer that we can analyze and convert from mathematical symbols to common sense human analysis. This is not the whole story. We need to do one more philosophical step where our old buddy or new friend Gauss should help us. So here is the coordinate x in our universe. Universe is one-dimensional because three-dimensional is too complicated. We just, our main goal is from simple to complicated. So there is origin, there is a like wave function of x, and we wonder what it will be at time equals 0, because we do know that the c sub n is integral psi x naught phi. Let's put different things m. One should put star either here or there, dx, right? So in order to practice this rule of predicting future, we need to find the expansion coefficients. We need to guess, or someone needs to give us suggestions on the initial wave function. We can predict the future, but we cannot predict the past. The past should be given to us, right? I feel someone falls asleep. It means I perform not enough funny. So if we want electron to be localized so that it is something that we can measure, study, it should be something with higher probability or probability amplitude near the center and then getting smaller. If you do parabola, it will go to negative. And there is no negative probability. So parabola doesn't work. If we, of course, we can do a sharp function just telling that it's linear here, linear there. Yeah, it's a good problem in a textbook, or one can even do simpler, like making a step function. But then it is a little strange to explain how it can be that there is a big probability and then 0 probability. How to explain these sharp edges? Just more safer. And I don't have more logical background. It's just a formulation of a problem. let's assume that initial distribution of an electron follows the function proposed to us by Carl Friedrich Gauss. So psi of xt naught will be e to the power minus x naught, which can be 0 squared, divided by some width parameter and with some normalization constant, which can also include this width parameter, and we just should keep German money with us to know exact functional form of this equation. So the strategy, the plan of our next 2 weeks is as follows. Well, one day will be taken for presentations on MATLAB, but not this Friday, not Monday, maybe in Friday next week, because otherwise we will fail in this math intense subjects or in homeworks, so we don't delay. So this is the initial wave function that we need to process and find the expansion coefficients. And then there is a necessity to find what are the basis functions for electron in the free space and what are the eigenenergies of these basis functions in the free space. Is it more or less okay? So this is, we are going towards mathematical formulation. The answer that we are going to get, we need to prove that the as time goes by, this distribution will change. And it may change, it may start oscillating, getting fringes. It may start shifting, with center moving somewhere. And it may start getting either thinner or more distributed. And it is what we need to answer mathematically. So do you have questions on strategy? So it's a plan for 2 weeks, and it is the simplest possible problem that will eventually motivate you to do simulations only rather than derivations, but we need to do a little. So towards a progress in this direction. I want to finish all non-mathematical philosophical things now and then go into just derivations when we meet next time. And yeah, we are late, but I'll postpone or like move material from one meeting to another. Let's believe for a minute to Sir Isaac Newton. So as you guys told me at the beginning, so if there is a momentum of a particle, it will keep this momentum, right? When we met, yeah, so my memory is weak. So momentum is kept. Momentum is kept. Another thing that Sam surprised me on one of our first meetings. He immediately digged out of his memory the uncertainty relation.
So what?
Uncertainty relation for quantum. Can you reproduce it once again? And he knows it. He was telling it to all of us.
The with the XY.
Just X and P or X and V.
I mean, but it didn't have to do with Euler's identity, right?
No. Before I started lecturing anything, can we know position for sure?
Oh no, yeah.
So it's uncertainty relation.
The position of an electron, you can't know its location. Or example was it is if you know position but not speed, or speed but not location. There's like velocity.
Something like H, right?
Yeah.
So their uncertainty, this delta variation of this together is always big. One cannot have zero uncertainty for both. And it means if the momentum is known for sure and it is kept, it will be kept forever, right? And from here, we get an idea that in a free space, for electron with known momentum, the wave function must be eigenstate of the momentum operator. Here you can pinch me and tell it is not enough logic, but if you don't, I'll just take and go forward. So from these two arguments, the wave function of electron in a free space must be an eigenstate of momentum operator. No one is protesting. Anyone against this statement? It means everyone is for it. Accept it as a ultimate truth. Democratic study of science. Now, momentum operator minus. Yes. How nice that we have editing options. Finding errors in lectures will be credited. Stay alert and try to find mistakes. I will give you tons of options, not intentional. Now, let's practice the derivative. So derivative of exponential is exponential, e minus I h bar px, and then everything except x comes here as a factor, minus I over h bar, and the p as a value, not the operator. And here we have minus I h bar. So h bar cancels. I times I will be minus 1, minus 1, minus 1, minus 1, which means here I need to have plus another correction. And then we will have value p times our original function, which we needed to prove, right? Okay. So the eigenvalues of momentum operator will be used here. So we found 1/3 of our answer. We will plug it into here. We need this epsilon sub n. We need to perform this operation and find c sub n, and then perform summation. Then we can analyze. I believe it's time to depart. Let me quickly just go through all slides. Basically, it is what we did, right? Gaussian function.
Oh, it's not on the screen.
It is not. So Gaussian function moving forward with constant velocity, plane wave, fat distribution with changing its width, eigenvalue of the momentum operator, initial. So this is a solution that we are going to get here, that we plan to predict future. And here is the just mathematical plan how to replace summation by integration and take it. So end of the meeting. Thank you for stopping by. Looking forward to see you at 5 tonight.
Yep.
A lecture in 1 minute.
Oh, Maria's fine.
Have a job to do. You're just gonna skip.
No. Oh.